A 70-kilogram person, standing on Jupiter. In the first second, their knees buckle. In the next few seconds, their spine compresses. Their heart strains to push blood upward against a force 2.5 times stronger than anything evolution ever prepared a human body for. Jupiter's surface gravity is 24.79 meters per square second, 2.528 times the pull of Earth. That number sounds almost manageable. Familiar, even. 2.5 times normal. The math tells a different story entirely. Today we run those numbers, and what they reveal about your body, your bones, and what actually waits beneath those clouds will shock you. Where are you watching from? Drop it below. And stay, because this gets stranger the deeper we go. Before the crushing, before the pressure, before any of it, you have to understand what Jupiter actually is. Because most people picture a giant version of Earth. A solid surface, thick atmosphere, maybe some exotic weather. That picture is completely wrong. Jupiter does not have a true surface. The planet is mostly swirling gases and liquids. A spacecraft would have nowhere to land, and it would not be able to fly through unscathed either. The extreme pressures and temperatures deep inside crush, melt, and vaporize anything that enters. So when we talk about standing on Jupiter, we are not talking about standing on rock. We are talking about the moment you enter the atmosphere and what happens from that point, second by second, layer by layer, as the planet slowly takes you apart. Start with the gravity alone. On Earth, you weigh whatever you weigh. On Jupiter, that number multiplies by 2.5 immediately. A person who weighs 70 kilograms on Earth suddenly carries the effective load of 175 kilograms. Imagine strapping weights equal to your entire body mass across every part of you: arms, legs, chest, skull, and then trying to stand up and breathe. Your legs would feel it first. The quadriceps, the muscles that hold you upright on Earth, would be working at 2.5 times their normal load from the very first moment. No training prepares a human body for this. Even elite athletes, people who spend their lives building strength, would find their legs failing within minutes under that continuous load. The spine is next. Earth's gravity already compresses the vertebrae across a lifetime. That is why you are slightly shorter in the evening than in the morning. The muscles in your lower body are always active, simply keeping you upright against Earth's gravity. Remove that familiar number, and everything changes. Amplify it by 2.5, and the compression is immediate and structural. Now here is the number the title promised. The math. If a 70 kilograms person stands in Jupiter's gravity, 24.79 meters per square second, the force pressing down on their body is 70 times 24.79 equals 1,735 newtons. On Earth, that same person experiences 686 newtons. The difference is not dramatic in a chart. In a body, it is the difference between standing and collapsing. The heart faces the hardest calculation. It must pump blood from the chest up to the brain, working against gravity to do it. On Earth, that distance and that force are what the human heart evolved for over millions of years. On Jupiter, the heart is suddenly fighting 2.5 times the resistance it was built to handle. When a person returns to Earth after months of even reduced gravity, their heart struggles to push blood upward, and they experience dizziness, pressure drops, and sometimes fainting. Jupiter's gravity does not give a heart time to adapt. It demands everything immediately. If this channel is new to you, subscribe now. What comes next is where the real science begins and most people stop looking. Jupiter's atmosphere has 3 distinct cloud layers spanning roughly 71 kilometers of depth. The top layer is ammonia ice. Below that, ammonium hydrosulfide crystals. The innermost layer is water ice and vapor. You fall through all 3, and each one changes what is happening to you. At the top of the clouds, with a parachute slowing descent, the atmospheric pressure would be comparable to Earth's surface. But as you descend, within about 5 minutes, you reach twice Earth's atmospheric pressure. Within 15 minutes, 10 times. The temperature has dropped to minus 40 degrees Celsius, and the winds, reaching 450 miles per hour horizontally, carry you sideways even as you fall straight down. NASA data confirms Jupiter is swept by over a dozen prevailing winds, some reaching up to 335 miles per hour at the equator alone. These jet streams reach depths of about 3,200 kilometers below the cloud tops. These are not gusts. They are permanent atmospheric rivers wider than continents. At 30 meters of water pressure, roughly the 4-bar level, a human diver on Earth would already feel effects on their joints and ears. On Jupiter, you pass that point in minutes. At the 10-bar level, The oxygen mixture in any breathing apparatus would need to change entirely, or the concentrated oxygen would become toxic to the brain. Jupiter's magnetosphere traps particles from the sun's solar wind. The resulting radiation exposure is lethal within hours before any of the pressure issues below even become relevant. So the real sequence of death on Jupiter is not one single event. It is a cascade. Radiation damages you from the moment of entry. The gravity overloads every muscle and organ simultaneously. The pressure climbs with every kilometer of descent. The temperature swings between extremes no suit has ever been tested against. And the winds move faster than a commercial aircraft. But none of that is the strangest part of this planet. The strangest part is what happens when pressure reaches its absolute peak, deep in the interior where no probe has ever survived and hydrogen itself stops being a gas. There is a thing inside Jupiter that does not exist naturally anywhere on Earth. A form of matter that took scientists decades to even believe was possible. And it is what makes Jupiter not just lethal, but alien at a fundamental, physics-rewriting level. About a third of the way to Jupiter's center, more than 3 Earth diameters deep, the pressure climbs to 2 million bars and the temperature reaches between 8,000 and 10,000 degrees Celsius. At that point, something extraordinary happens to the hydrogen. The pressure squeezes atoms so tightly that their electrons break free and flow throughout the liquid, allowing it to conduct electricity like a metal. Hydrogen, the lightest element in existence, the gas that fills birthday balloons. Crushed so hard it becomes a metal that conducts electricity. This is liquid metallic hydrogen, and it exists nowhere on Earth's surface under any conditions humans can create. Scientists believe this metallic hydrogen ocean is the source of Jupiter's uniquely intense magnetic field. A magnetic field so powerful it extends past Saturn's orbit. Generated not by iron and rock like Earth's core, but by an ocean of crushed, electrified gas behaving like a conductor. At the very center, the core pressure reaches approximately 45 million bars, equivalent to the weight of 1,000 elephants balanced on a stiletto heel, focused on a single point. The temperature there is around 20,000 degrees Celsius, more than 3.5 times hotter than the surface of the sun. Any human body, any material engineered by humans to date, ceases to exist as a recognizable structure long before reaching that depth. Not crushed in the way a can is crushed, dissolved, atomized, absorbed into layers of exotic matter that do not follow the physics of anything built on Earth. There is something I held back at the start of this video, a fact about Jupiter's gravity that changes how you understand every planet in the solar system, including Earth. Here is the twist hidden inside the math. Jupiter's mass is 317.8 times that of Earth. Yet its surface gravity is only 2.528 times stronger. How? Because Jupiter is enormous. Its radius is so large that you stand much farther from the center of mass than you would on a denser planet. A white dwarf star, the dead remnant, our sun, will eventually compresses the mass of a star into something the size of Earth. The gravity on a white dwarf's surface is roughly 300,000 times Earth's. A neutron star is worse, still millions of times stronger. Jupiter, for all its violence, is not even close to the extreme end of what gravity can do. Jupiter took most of the mass left over after the sun formed, ending up with more than twice the combined material of every other object in the solar system. It has the same ingredients as a star. It simply never grew massive enough to ignite. That is what Jupiter actually is. A failed star. Close enough to stellar physics to produce metallic hydrogen and a magnetic field that dwarfs every planet in the solar system, but not quite enough to become the second sun that would have made Earth permanently uninhabitable. The planet that could have killed us by existing. Instead, it kills anything that enters it. There is one moon orbiting Jupiter right now where liquid water sits beneath a frozen shell, and NASA's Europa Clipper launched specifically to find out if something is alive in it. Watch that video next. It is the single most credible location for life beyond Earth, and it is already in our solar system.